From previous lectures, you have got a good idea about the origin and evolution of our solar system and universe. Now you know why water exists in liquid form on our planet Earth. However, have you ever thought that why the Earth has so much water and how the oceans on the Earth's surface formed? Or how the presence of water in vast amounts on the Earth's surface influence the evolution of life? Or do we have water beneath the surface of Earth as well? This lecture is designed to answer some of these questions. An ocean-free Earth existed perhaps for several hundred million years as a consequence of extremely high surface temperatures following planetary accretion. The formation of oceans on Earth requires no less than a global scale cooling of Earth's surface to the temperatures at which water is stable in the liquid phase. Today, the Earth is a hydrous planet. However, the origin of water on the Earth and the reason why there is so much water on the Earth than other planets of our solar system is not completely understood. Scientists continue to debate two competing hypotheses to describe how water may have accumulated on the Earth's surface over past 4.6 billion years in sufficient quantities to form the oceans. These two hypotheses fundamentally differ from each other. First hypothesis says that water was mostly in the atmosphere and slowly it ingassed via the processes such as dissolution into an originally molten planet and later subduction through a solid one. Scientists supporting this hypothesis favor a late veneer. According to second hypothesis, water was originally contained in the interiors and it outgassed via volcanism. According to the first hypothesis, our planets formed dry with high energy impacts, creating a molten surface on the infant Earth, and any water molecules that were present as the planets were forming would have evaporated or been blown off into the space. The asteroids striking the Earth soon after its infancy delivered an extra layer of material. This late veneer may have included precious metals and volatile substances such as carbon, water, which are known to exist on a type of asteroids called carbonaceous chondrite. For that reason, it was thought that surface water as it existed on our planet today must have come much later, hundreds of million years later. Ancient sedimentary rock deposits and lava that cooled into characteristic pillow shapes provide irrefutable evidence that liquid water has existed on the Earth's surface for at least 3.8 billion years. However, if the late veneer hypothesis is correct, then there might not be any ocean or sufficient water for a much longer time of period. It is also argued that there is no way that celestial objects could contribute that much water. Recent research suggests that late veneer come from inner solar system where volatile substances are rare and that these asteroids therefore were not the main source of water on the Earth. Let's talk about the second hypothesis. However, to rightly understand the second hypothesis, first we must be well aware about the internal structure of the Earth. The evolved Earth consists of four concentric layers: inner core, outer core, mantle, and the crust. The inner core is a solid one and it's in the center of Earth, is the hottest layer with a temperature of 5500 degrees Celsius. The outer liquid core surround the inner core is also very hot. Mantle is the widest layer and is around 2,900 km thick, and it's made up of semi-molten rock which is known as magma. The outer crust of the earth is 0 to 60 km thick and is composed of several large pieces of land which are known as plates. The second hypothesis favors an inside-out mode of the origin of water. According to this hypothesis, the earth held onto some water when it formed, deriving from the ice in the nebula of gas and dust that eventually formed the sun and the planets about 4.5 billion years ago. Some of that water has remained with the earth and might be recycled through the planet's mantle layer. Water is stored in the earth's mantle in the form of hydroxyl groups. When the mantle rocks melt, the water dissolves in the magma. As the magma rises towards the surface and cools, the pressure is reduced, crystals are formed, and the water is released and emitted as water vapor through volcanoes. There was a long period of massive volcanic eruption in the Earth's history, thus releasing a huge amount of gas and vapor. A vast layer of volatiles accumulated gradually over initial million of years, and with continual degassing of the Earth's interior, the gravitational force of the Earth prevented these volatiles from leaving the planet. This proposed that water remained in form of gas until the Earth's surface cooled to 100 degrees centigrade, and thereafter it rained for several thousand years. As the water drained into the great hollow in the Earth's surface, the primitive oceans came into the existence. At the initial stage, degassing dominated the composition of primitive atmosphere, and it was entirely different from the composition what we see today. Over the period of time, atmosphere and magma equilibrated and the stability was established. The second hypothesis received a great flip recently with an amazing discovery of the huge reservoir of water 700 to 1000 km deep in the Earth's mantle. According to this discovery, the water is contained inside a blue rock called ringwoodite. This huge and deep reservoir contains water 3 times the volume of all the oceans deep beneath the Earth's surface and has linked to the origin of Earth's water. This discovery supports the idea that the Earth had water from the start and the oceans were formed when water oozed out of the interior of the young Earth.